Fast forward, and our contract is deployed and ready to go. We can already see our expanded implementation in use. GetBalance, which before had no input, now receives the user ID as input, and we can see that user number 10 has 0 in their balance at present. We can use increase balance to give the given user, number 10, an extra 1,000 in their balance. Note that beforehand, increase balance only received the amount changed as input. By invoking getBalance again, we should see that our user has now had their balance increased to 1,000 appropriately. One extra thing to note at this point is that we can also use Starknet call instead of Starknet invoke for functions that usually are allowed to change the state of our contract in order to use them without changing the state. What this means is, for example, I can use this previous invocation of increase balance, but this time use it with Starknet call, and instead of receiving my transaction ID as I did before, I get nothing. What this did was it's sort of a dry run of this function. It's not going to change the balance, but it indicates to me that when performing this, if I have no error received, this function is performing as I expected, and I'm safe to send it to the Starknet system. I'll produce another example. In this case, we'll do increase balance again, but not provide a user ID. In this case, I get the appropriate error message, and I know before committing this as a transaction to the system that this invocation will not succeed. That's a neat trick to use call versus invoke in this context. Furthermore, just to illustrate, we can use getBalance again on a different user, let's say user number 30, and we can see that even though user 10 has had their amount increased by 1,000, user 30 still remains at a resolute 0. And this is true for any arbitrary user we'll select at this point. Our getBalance, or it just calls our balance storage variable, which by default allocates to any user that hasn't been allocated thus far a default value of 0.